All right, this is CS 2810, Computer Systems and Organization, and this is assignment 4. So in this assignment, we build a register file, a program counter, and then different size RAMs. So here's the register file to start. This is my implementation of it. As you can see, we use a demultiplexer and a multiplexer, and some registers to have this register file. So what we can do is let's write to 000. Let's write the value 1. We'll load that. And then obviously both of our read addresses are 000. So our read data is a 1 basically. We'll turn the load off. We'll make the write data. We'll just put all these 1s here for the write data. We'll make the write address 1, and let's load it. All right, so now if we make read address 1, 0, and read address 2, 1, you can see read data 1 is just the value 1, and read data 2 are all these 1s. So basically you can store 2 different values in this register file. And you saw how you could load and have the write data. So that's the register file. This is the PC, the program counter. And this is my implementation of it. So let's just reset it. And then let's start the incrementer. That's going really fast. Let's turn the frequency down to 1 kilohertz. Let's see, is that good? We'll reset again. So you can see it's counting up. Still kind of fast, but you can see it count up. And then obviously the reset works as well. You reset it. And then another cool thing is you can load a value in. Let's just load, I don't even know, is it 16 bits? So 2 to the 16th power, we'll load that in there. And then it's loaded. And now if we want to increment, that's how it works. So that's the program counter. Now onto the RAMs. This is my 8-bit. Is it 8-bit? I think it's 8-byte RAM, because each register has 8 bits. No. Okay, anyway, I don't know. But this is my RAM 8, and we have 8 registers of 16 bits. So if we have address, let's just give it address 111. And let's load the value 1 into it. You can see that works. Now, let's in address 011, let's load the value like this. You can see that works on the output. So address 111 gives us the value of 1. Address 011 gives us the value of all those 1s. And then we just build up from here. So this is RAM 8 made of 8 16-bit registers. Here's RAM 64 made of 8 RAM 8. And it works exactly the same way. I'm not going to go over this because, as you can see in this separate file, which I just have them in 2 separate files because performance issues, we have a RAM 64. Oh no, this is an example, sorry. We have a RAM 512 made of RAM 64s. We have a RAM 4K made of RAM 512s. And then the biggest one we have is this RAM 16K, which holds a lot of data. So in the address 000, in the address 1, how about, let's store the value 1. We'll load that. Oh, so I need to start the clock for this to work. Let's see if that'll work. There we go. Okay. So now in the address value 3, let's store the value, that value. Okay. So just to see, address 1 stores that, address 3 stores all that. And I'm just switching between the addresses right now. Now let's store an address 111, and with all those zeros, let's just store all these 1s. The input will just all be 1s. Load it. Okay. And now watch, as I change the address, you can see what's changing on the output. So yeah, we have a lot of storage with all these RAMs. So yeah, basically in this assignment we built a RAM, we built a program counter, and a register file.